Good afternoon from Spain, and thank you very much to Accespro for inviting me to this great event. I'm Daniel Saez, and I'm the Strategic Intelligence and Technology Transfer Director in ITI Technology Center. And I'm going to talk about data as the key enabler of digital transformation in industry. Let me start talking about key enabling technologies as the big disruptors that will create a huge impact in the near future. And let me show these technologies in action in this short video from the CES 2020 Las Vegas. See in the video, artificial intelligence, new materials, life sciences, cybersecurity, IoT, and others are creating innovations in various economic sectors. They also will cause high disruptions in the economy and society in the next 10-15 years, facilitating the development of new goods and services and restructuring the industrial processes to modernize the industry and favoring the transition towards a knowledge-based and sustainable economy. Key enabling technologies require high degree of research and development, combining science, technology, or engineering. With fast innovation cycles, they also need high capital investments in infrastructures, equipment, and also personnel. And as we can see in the video, they are a combination of physical and digital innovations. Key enabling technologies provide substantial impact on the creation of highly qualified employment, improvement of the quality of life, and future prosperity. They have a systemic relevance in all phases of product development. They are a key ability to improve health, safety, sustainable development, and connectivity between systems and individuals, and they enable multiple industrial applications in multiple sectors, contributing to the generation of global excellence, new knowledge, and new forms of participation. Data is present in some of those key enabling technologies. As you can see in these figures, in Europe, data technologies will cause a very big impact in the economy of the next few years. Also in the employment and the skills that workers will need to extract and also provide value to this new economy. So we can say that among all the key enabling technologies, those that are based on data are the ones that are providing and will provide the biggest impact to economy and society, because data is the lifeblood of economic development. Data is the basis for many new products and services, driving productivity and resource efficiency gains across all sectors of the economy, allowing for more personalized products and services, and enabling better policy making and upgrading governmental services. Data are essential, an essential resource for startups and small and medium companies, and data is also essential for training artificial intelligence systems, with products and services rapidly moving from pattern recognition and insight generation to more sophisticated forecasting techniques and then better decisions. Here you have more figures, in this case related to artificial intelligence revenues worldwide, and where you can see that in the next few years the increase of revenues will be exponential. So we can say that data is the core element in digital transformation. Data is the fuel, but data needs to be worked to be able to extract value from them. In that sense, there are a set of digital enablers around data which cover all the data cycle. Since the gathering of and collection in a reliable way, the communication using wired or wireless technologies like IoT or 5G, the distribution of data storage and processing, and also the traceability of data with technologies like edge, fog, and cloud computing or blockchain, the analysis of huge amount of data with big data analytics techniques, the processing of complex small data with statistical or meteoristical techniques, and last but not least, the simulation and prediction of scenarios using deep learning or pattern recognition technologies. These are the key data technologies, and we have to add the cybersecurity and also data visualization technologies with augmented or virtual realities. In all this data ecosystem, common data innovation spaces emerge as a reference structure and models that can generate knowledge and technologies and provide neutral infrastructures and information about data-driven technologies and data sharing options and assess in a personalized way to companies in order to take decisions about technology investments or business models in the digital economy. At the same time, these data innovation spaces are single windows that are prepared to deploy pilot projects and technology tests in lab environments as a previous phase to the investment in a technology or the launch of a product to the market. As you can see, data innovation spaces are composed by three main pillars: infrastructures, data, and algorithms. And another important one, which is people, with knowledge to deploy the infrastructures and develop and configure the algorithms to build solutions to different sectors. Because data-driven applications can be applied to different sectors. The most important ones for us are these 5 ones. Manufacturing industry, where predictive maintenance, digital twins, quality control, optimization, and other solutions can be developed. Health, where we can improve diagnosis and prognosis of diseases, optimize the hospital operations, or personalize the medicine with omics and genomics. Tourism, buildings, and cities, where energy efficiency or anomaly detection solution can be useful. Agriculture, with precision control systems and autonomous tractors or personalized nutrition. And finally, transport, with route optimization of autonomous vehicles, for example. Those are examples of applications of data technologies. And going in depth in industry examples, I'm going to talk for a few minutes about relevant data-driven innovative use cases in industry. And I will base the explanation in some examples of projects developed by ITI in the last few years. So just a brief overview about ITI. ITI is a technology center and a digital innovation hub called the Data Cycle Hub, working on those technologies that we have seen before around data. With more than 200 professionals and a very close link to the Technical University of Valencia, ITI is also a private association of companies with more than 240 members that in fact is the biggest association of ICT companies in Valencia region. ITI was born in 1994 with the mission of doing research and development activities and transfer technologies to the market in order to improve the industrial competitiveness. So we have knowledge, we also have infrastructures, and we generate technologies to answer technology and business challenges of companies and also public administration, helping them in their research and digitalization activities. Now, going to the examples, let me start with this project focused on data technologies to improve quality in the manufacturing processes, and which represents in a very broad sense the impact of those technologies in industry.
Today, industry is changing. In fact, it's currently immersed in its fourth revolution, Industry 4.0. ZDMP is a European-scale project with a goal to establish a digital platform for connected smart factories for achieving excellence in manufacturing through zero-defect processes and products. Industry 4.0 is based in connectivity between the different entities and partners that exchange information in real time. Data sharing provides many advantages, but also great complexity. ZDMP reduces effort by opening opportunities, like process efficiency and product quality through machine learning, data analysis, and automated workflows. ZDMP achieves excellence in manufacturing by establishing a reference digital platform and related applications, so-called ZApps, to reach zero-defect processes and products. By using ZDMP, manufacturers can get detailed information of every process, every product, leading ultimately to a higher quality of the finished product. ZDMP will allow technology providers and software developers to easily build and deploy ZApps to serve the needs of the manufacturing market. In fact, the platform has an application builder that allows the creation of ZApps fully adapted to the specific needs of every partner and industry domain. For example, thanks to artificial intelligence algorithms deployed by ZDMP, it is easy to predict potential defects which affect the quality of the final product even before they take place. The platform analyzes information and makes it possible to optimize settings to reach the highest quality in the final product and optimize production processes to reach higher quantity. ZDMP will validate itself in industrial demonstrators in the fields of automotive, machine tools, electronics, and construction. These will show how enhanced cooperation between companies can avoid and reduce product and process defects along various supply chains. ZDMP is a project involving 30 participating organizations, including users, technology companies, research centers, and universities, and is supported by the European Commission.
Well, as I mentioned before, you have seen that it is a very interesting Lighthouse project, covering all the data cycle and showing how data technologies can help to one factory and also the complete chain of connected factories to improve operations and quality. In the project, we have provided artificial intelligence and big data technologies to predict defects in the manufacturing of engines of Ford Motor Company, and we are achieving very good results. Now, we will continue with other more specific examples. Another area where we are working very hard are the digital twins. Digital twins are virtual representation of real devices or processes that allow working on systems without affecting the real production processes. In the development, for example, of new monitoring, simulation, or optimization applications. As we can see in the left side of the slide, a digital twin is composed by two phases. The first one is the digitalization phase, in order to get more information about the processes and the machines as possible, and where IoT technologies are used. The second one is the application of big data analytics and artificial intelligence technologies to simulate or predict situations before going to the real operations. The digitalization phase can be facilitated by technologies like this one, which is called Deploy and Forget and has been developed by ITI. This technology allows the monitoring of any variable in any place of the shop floor with a very simple network of nodes that we can see here in the image. The application of digital twins are multiple, like, for example, simulation of new production scenarios, predictive maintenance, monitoring of operations and performance, or optimization of processes. And now we can see an example of a digital twin of a production line in this video, where we can see different ways of configuration of the line and see what is happening with the overall equipment efficiency, the availability, the performance, and the quality, and where we can make some changes, launch the simulation, and get the results, and then decide how to go to the real operation. Now we are seeing that we are composing the line, we start the simulation, and we get the results where we can see the overall equipment efficiency of each of the machines in the line, and we can make changes. We can analyze in each moment which is the value of the variables. These concepts and other related to big data and artificial intelligence have been worked with the engine plant of Ford Motor Company in Valencia, where we have improved the energy efficiency by means of anomaly detection in energy consumption in the shop floor. Also, the overall equipment efficiency, detecting inefficiencies and bottlenecks. And also, we have done predictive maintenance by means of predicting wear and also detecting anomalies. This project has been and is a real challenge for big data, because we have to monitor 9 sensors in different frequencies, generating 2 million registries per day, which is 1 gigabyte data per station per day. We have 24 stations per operation, 12 operations per line, and 2 lines. So this is a very huge amount of data to manage, with a conventional configuration of computing architecture, the analysis would take around 14 hours. With big data technologies and architecture that we have developed, we reduced to 9 minutes. So this is an example of how big data technologies can improve the process of huge amount of data. These are some examples of the screens that on the scoreboards we generate to Ford for decision support using multivariant and univariant anomaly detection techniques. Now another example related to data visualization. It is called JOG Virtual Reality, that has been developed by an ITI researcher professor in the Technical University of Valencia and represents a complete and detailed warehouse where, using virtual reality glasses and 2 remote controls, workers can interact with all the elements of a warehouse in a very realistic way and simulate different situations. And also it is very useful for training the workers before going to the real situation. And finally, I would like to talk about Data Room, which is the biggest project we have developed in 2020. It is the first laboratory in Europe for demonstration and experimentation with data for Industry 4.0. We have created a fab lab with a real production line which is manufacturing mobile phones and consists of flexible manufacturing cells, robotics, automated warehouses, and other elements in the production line, and where we have deployed all the data technologies where ITI is working, like the digital twin, other artificial intelligence and big data applications, quality control by artificial intelligence, deploy and forget technologies, or cloud computing. And to finish, I would like to share this sentence with you. A region which specializes in data is committed to growth, and in fact, it will grow. It's committed to the knowledge economy, the well-being, and the quality of life of the citizens. So thank you very much, and I will be glad to answer the questions in the debate later.